Here we have a standard hydrogen electrode. In the standard hydrogen electrode, we have hydrogen gas being pumped in, and the pressure that the hydrogen gas is going in is 1 atmosphere pressure. The gas is being pumped into a solution of hydrogen ions, and the hydrogen ions are in contact with the hydrogen gas with a platinum electrode, which is inert. Connecting the hydrogen electrode to the next half cell is a salt bridge. The salt bridge is made up of potassium ions and nitrate ions, and these electrolytes do not react with the electrolytes in your beakers. The purpose of this salt bridge is to allow for the charge and balance and to complete the circuit. So let's go back. We've got our hydrogen ions, we've got our platinum electrode. The concentration of the hydrogen ions in the beaker is 1 mole per dm cubed, and the temperature is 298 Kelvin. So let's now go and choose a half cell. Let's go for a copper electrode. When copper is immersed in a solution of its ions, copper ions at 1 mole per dm cubed, exactly the same temperature, we can see here a recording on our high resistance voltmeter. The value that's recorded is plus 0.34 volts, and that tells us that the copper electrode is the positive electrode, and if electrons were allowed to flow and we were to remove the high resistance voltmeter, we can see that electrons would flow from the hydrogen electrode to the copper electrode. Thus, copper ions would become reduced to copper metal, and the hydrogen would get oxidized to hydrogen ions. That is if the high resistance voltmeter wasn't there. When the high resistance voltmeter is there, current isn't allowed to flow, and this shows the difference in potential for the copper half electrode to gain electrons and for the hydrogen electrode to lose electrons. Let's now change the half cell on the right. Let's change it to a non-metal chlorine. This gives a standard electrode potential of an even greater value of plus 1.34 volts. Now, in the chlorine half cell, we can see that chlorine gas is being pumped in at 1 atmosphere pressure, and again, we have a platinum electrode. The platinum electrode is there to conduct electricity, but is inert and doesn't take part in the reactions. Because the chlorine gas has a positive electrode, that means that the chlorine gas is taking electrons and being reduced to chloride ions. Whilst in the hydrogen electrode, if electrons were allowed to flow, if the high resistance voltmeter wasn't there, then the hydrogen would lose electrons and become hydrogen ions. But because the high resistance voltmeter is there, it shows the potential difference between the two half cells. Let's now choose another half cell.